Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the points. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Here we are required to obtain the orthographic projections of the point F, which happens to lie into the horizontal plane and 20 millimeter behind the vertical plane. Now we will be evaluating the front view, top view, left hand side view and the right hand side view orthographic projections of this point F over here. Now as we know that this point happens to lie into the horizontal plane and behind the vertical plane, so this point will be located into the second as well as third quadrant of the orthographic projection system. Now here we can check, we have been provided with horizontal plane, the vertical plane, the left profile plane and the right profile plane, which have been arranged into the mutually perpendicular directions in the spatial arrangement, which has provided us with the four quadrants over here. So this is the location of the first quadrant, this is the location of the second quadrant, this is the location of the third quadrant and this is the location of the fourth quadrant. So now we can check, as we look at this point F location over here into the space. So this point F happens to rest onto the horizontal plane. So this point F will be located over here. Another coordinate of this point F which is available with us, that it is lying 20 millimeter behind the vertical plane. So here we have identified the spatial location of this point onto the horizontal plane. So here we have got this portion of the horizontal plane which is lying behind this vertical plane, and the distance of this point from the vertical plane happens to be equal to 20 millimeter. So this way we can now conclude that this point F, it happens to lie into the second quadrant as well as the third quadrant, because it is resting onto the common horizontal plane which is going to divide second and the third quadrants over here. Now as we are going to obtain the front view, top view, left hand side view and the right hand side view orthographic projections of this point F onto different reference planes, so we observe that the orthographic projections which will be obtained onto the horizontal plane, vertical plane, left profile plane and the right profile plane, that these projections will be available onto the mutually perpendicular reference planes over here. So we need to carry out the rotations of horizontal plane, left profile plane and the right profile plane, so that all of these orthographic projections, they can be obtained into a single plane of projection over here. So now we can check this portion of the horizontal plane which is lying behind the vertical plane. So it will be rotated in the clockwise direction, in the upward direction, about this XY hinge over here. So this is the XY reference line. Then this left profile plane, so this will be rotated in the leftward orientation about this vertical hinge over here. Similarly, this right profile plane which is available over here onto the right side of the vertical plane, so this will be rotated in rightward orientation about this vertical hinge over here. So this way we will be able to obtain all the orthographic projections of this point F into a single plane over here. So let us now evaluate the orthographic projections of this point F, which happens to lie in the horizontal plane and 20 millimeter behind the vertical plane. Now we can check, this is the horizontal plane, this is the vertical plane that we have got. So now as this point F, it is resting onto the horizontal plane, so we are going to obtain the location of this point F in the horizontal plane at a distance of 20 millimeter behind the vertical plane. So now the spatial location of this point F into the second and the third quadrants has been appropriately obtained into this coordinate system over here. So now we need to obtain the front view orthographic projections of this point F. So as the observer is going to look at this point F from the front view orientation, so we observe that we have obtained the front view orthographic projections of the point on the XY reference line, because this point F happens to rest onto the horizontal plane. Now as the observer is going to look at this point F from the top view orientation, so we observe that the top view projection small f, it has coincided with the original location of the point F onto the horizontal plane. So now we observe that this top view projection small f and this front view projection f dash, so both of these orthographic projections, they are lying in the mutually perpendicular planes over here. So now in order to obtain both of these projections into a single plane of projection, we need to carry out the clockwise rotation of this portion of the horizontal plane which is lying behind the vertical plane over here. So this portion of the horizontal plane, it will be rotated appropriately in the clockwise direction or into the upward direction over here, so that we will be obtaining the overlapping of this vertical plane and this horizontal plane over here. So now this point F has to be obtained appropriately onto this vertical plane. We keep the radius is equal to 20 millimeter and draw an arc so that this point small f, that is top view projection, it can be appropriately transferred onto the vertical plane. So now we have been able to obtain the front view projection and the top view projection into a single plane over here, that is onto the vertical plane. We have obtained both of these projections over here. Now let us obtain the left hand side view orthographic projections of this point F over here. So in order to obtain the left hand side view orthographic projections, here we have drawn the left profile plane towards the left hand side of this vertical plane, and this left profile plane, it will be perpendicular to horizontal plane as well as the vertical plane. So now we can check, as the observer is going to look at this point F from the left side orientation, now this point F will be projected appropriately onto the left profile plane alongside the XY reference line over here. So we observe that even in the profile plane projections, this point F double dash left hand side view projections, so it will be available on the horizontal plane onto the left profile plane. Next, we have obtained this right profile plane which is perpendicular to the horizontal plane and the vertical plane towards the right hand side of the vertical plane over here. So now when the observer is looking at this object or the point F from the right hand side orientation, now this point F will be appropriately projected on the right profile plane onto the XY reference line, that is onto the horizontal plane over here. So the right hand side view projections, they have been obtained onto the right profile plane. And now we observe that since this left profile plane and the right profile plane, they happen to be perpendicular to the horizontal plane and the vertical plane, that is front view projections and the top view projection. Therefore, we need to carry out appropriate rotations of this left profile plane and the right profile plane. So here, as we have already discussed, left profile plane will be rotated in the leftward direction about this vertical hinge available over here. Similarly, the right profile plane, it will be rotated towards the rightward direction about this vertical hinge available over here. Now, as we have discussed that this point F, it happens to lie into the second quadrant as well as the third quadrant over here. So this way we are going to now introduce left profile plane into the third quadrant. We have introduced right profile plane into the third quadrant as well. So now whether we assume this point into the second quadrant or we assume this point into the third quadrant, the same projections we are going to obtain, because even in the third quadrant also this horizontal plane would have moved in the upward direction and this left profile plane would have moved in the leftward orientation, and even in the third quadrant this right profile plane, it would also have moved alongside the rightward direction over here, because this point F, it lies onto the common horizontal plane, which is the common point between this second quadrant and the third quadrant. So the same projections, they would be available even if we had assumed that the point F, it is going to lie into the third quadrant. So now let us obtain the orthographic projections of this point F onto a single plane. So here we have obtained the XY reference line, now corresponding to the left profile plane, which is this left profile plane available over here into the 3D spatial arrangement. So we have obtained X1 Y1 reference line. Similarly, corresponding to this right profile plane, which is available onto the right hand side of the vertical plane, we have obtained another vertical reference line, that is X1 Y1 reference line corresponding to the right profile plane. In order to obtain the side view orthographic projection, so here we have drawn one transfer line originating from the intersection of the XY reference line and left profile plane X1 Y1 reference line, and this transfer line happens to be inclined at an angle of 45 degree with respect to the XY reference line, and this transfer line will be used to transfer this distance of 20 millimeter from the vertical plane into the profile plane projections over here. Similarly, towards the right side also we have obtained another transfer line corresponding to the right profile plane, and this transfer line we have obtained corresponding to the intersection of XY reference line and X1 Y1 reference line corresponding to the right profile plane. And once again, this transfer line is inclined at an angle of 45 degree with respect to XY reference line, and again we are going to transfer this distance of 20 millimeter from the vertical plane into the profile plane using this transfer line. Now when the observer is going to look at this point F from the front view orientation, so we observe that this point F dash will be available with us onto the XY reference line, that is front view orthographic projections F dash, they have been obtained onto the vertical plane at the XY reference line available over here. Now we also know that the top view projections, they were obtained onto the horizontal plane over here at a distance of 20 millimeter behind the vertical plane, but because the front view and the top view orthographic projection, they were available in mutually perpendicular orientations, so we had to rotate the horizontal plane in the clockwise direction. So now in the rotated view we have obtained the location of this top view point F at a distance of 20 millimeter above the XY reference line. So from point F dash we have taken a distance of 25 millimeter above the XY reference line, and we have been able to locate the top view projection of this point F onto the horizontal plane, because it is the horizontal plane which has been rotated to merge or coincide with the vertical plane over here. Now let us obtain the side view projections of this point F. So first of all we are going to obtain the left hand side view projections of this point. Now when the observer is going to look at this point F from the left side orientation, so we observe that this point F has been projected alongside the horizontal plane onto the left profile plane available over here. So now we can check this distance happens to be 20 millimeter. So this distance of 20 millimeter behind the vertical plane we will be able to obtain once we draw a horizontal projector line through this plan projection point F onto this transfer line, so that this distance, which was 20 millimeter behind the vertical plane, so it will be transferred into the profile plane using this transfer line. So wherever this horizontal projector line, it intersects with this transfer line over here, which is available towards the left hand side. Now here, from this intersection point, we are going to draw a vertical projector line. Now we can check the distance of this vertical projector line from the vertical plane. It happens to be equal to 20 millimeter because this angle of inclination is 45 degree. So this distance will be equal to this distance. So now once we obtain a vertical projector line through this transfer line, now we have to extend this vertical projector line up to a horizontal projector line which is emerging from the point F dash, because the elevation of this point F or the front view of this point F, it happens to rest onto the horizontal plane or the XY reference line. Therefore, the side view projection will also lie onto the XY reference line. We have already checked. We had obtained the left hand side view projection onto the XY reference line or the horizontal plane. So now wherever this vertical projector line and this horizontal projector line, which is emerging from the point F dash, they will be intersecting. So this intersection point has provided us with the location of the point F double dash into the left hand side view projections, which are obtained onto the left profile plane over here into the second quadrant or the third quadrant. Now let us obtain the right hand side view projections of this point F. So once again, this distance of 20 millimeter from the vertical plane needs to be transferred onto this right profile plane. It should be this distance over here. So now once again we are going to obtain one horizontal projector line through this plan projection point F, extend this horizontal projector line till it intersects with this right side transfer line over here. Now wherever this point of intersection will be obtained, from this point of intersection we are going to obtain a vertical projector line such that this distance from the vertical plane will be appropriately transferred into the right profile plane over here. Now we can check this vertical projector line. It is at a distance of 20 millimeter from the vertical plane, that is the right side of the vertical plane. So now this distance is 20 millimeter. So now wherever this vertical projector line, which is emerging from this transfer line corresponding to point F, wherever it is going to intersect with this horizontal line which is emerging from the point F dash, indicating the height of this point F dash from the ground or the horizontal plane, which is 0 over here, since this point F happens to lie into the horizontal plane. So this intersection point of this horizontal projector line and this vertical projection line, so it will provide us with the location of the point F double dash, that is right hand side view projections over here into the right profile plane. So now we can conclude that the right hand side view projections of a point into second quadrant or the third quadrant, they will be available on the right hand side of the front view orthographic projections over here. So this way we have been able to obtain front view orthographic projections, the top view orthographic projections, the left hand side view orthographic projections, and the right hand side view orthographic projections of a point which is resting into the horizontal plane at a distance of 20 millimeter behind the vertical plane. That is, this is a point F which happens to lie into the second quadrant as well as the third quadrant over here. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the points in the coming lectures. So thank you very much. Thanks a lot.